All right, let's jump right into this explainer and cut straight through the massive hype surrounding AI agents. You know, everyone today claims they're building them, but the engineering reality? Well, it's a whole lot more complicated than those shiny little demos might suggest. So we're going to uncover what actually separates a convincing prototype from a hardened, reliable production system.
We've got a really packed agenda today. We'll start off with the AI agent reality check, compare chatbots versus AI agents, break down the 3 core components, look at choosing your autonomy level, and finally wrap up with avoiding common production pitfalls.
Okay, kicking things off with Section 1, the AI agent reality check. To really set the stage for us here, let's look at this fascinating contrast pulled straight from the LangChain 2025 State of Agent Engineering report.
Now get this, what's really wild is that over half, 57% to be exact, of surveyed teams claim they already have AI agents running in production right now. That's up from 51% last year. Hearing that, you'd probably think adoption is absolutely everywhere and the tech is totally solved, right? Well, not quite.
Because here is the actual friction. Nearly a third, 32%, of those exact same teams cite quality as their #1 production blocker. That proves there is just this incredibly painful gap between getting a flashy demo to work for a quick 2-minute Twitter video and actually achieving reliable engineering in the real world. A lot of teams are building these things for sure, but they are seriously struggling to make them work consistently.
Which brings us to Section 2, chatbots versus AI agents.
To bridge that production gap, we have to completely rewire our mindset away from standard LLM apps. I know we throw the terms around interchangeably, but under the hood, they are profoundly different. Think about who actually controls the workflow. With a standard chatbot, you are the one driving the car. You ask it to write an essay, and it gives you a single-shot generation. If it messes up, you ask for a revision. But with an AI agent, the LLM takes the wheel. You just give it a high-level goal, and it autonomously decides its own next steps. Searching, drafting, evaluating, all until it decides it has solved the problem.
But letting the model control the workflow is super risky because agents are chaining dozens of calls together. Tiny little errors compound incredibly fast. To put that into perspective, a mere 5% error rate per step, like maybe a slight hallucination or picking the wrong tool, that snowballs into a massive 40% chance of complete failure over just a 10-step chain. This right here is exactly why these systems are literally so hard to push to production.
Moving right along to Section 3, the 3 core components.
To prevent those catastrophic failures we just talked about, we need to pop the hood and examine the rather fragile anatomy of an agent across 3 foundational pillars. First up is memory. This operates on a few different levels: short-term context, working scratch pads for intermediate math, and long-term external persistence like vector databases. And surprisingly, this is still a massive weak point in the industry. Without explicitly building a persistence layer, your advanced agent is really just a temporary chatbot with pretty severe amnesia between sessions.
Next up is planning and reasoning. This is basically the brain of the operation. It takes these massive goals and breaks them down into subtasks using prompting frameworks like React or Tree of Thoughts. But here's the catch. If the model hallucinates a bad plan up front, it will confidently run down this incredibly expensive rabbit hole, literally burning through your API tokens without ever actually reaching the goal.
And finally, we have tools. Think of tools as the hands of the agent. They're the bridges to the real world, like APIs, file systems, or databases. But the absolute secret to getting them right? The tool descriptions must be written specifically for the agent to understand, not the human developer. If your description is even slightly vague, the agent is going to call the tool at the wrong time or with the completely wrong arguments. You literally have to treat your tool definitions with the exact same rigor as your prompt engineering.
It's also really worth noting that behind the scenes, this architecture is getting super complex. A massive 75% of teams are now using multiple models in a single agent system. So they aren't just using one massive model for everything anymore. They're combining a heavy, smart model for that deep reasoning and planning with a much faster, cheaper model just for executing the tools or summarizing the data. It's a highly optimized tag team approach.
All right, Section 4, choosing your autonomy level.
Now that we deeply understand the architecture, we're faced with the single most important design decision. How much leash do we actually give this system? Well, autonomy isn't just an all-or-nothing switch. It actually spans 5 distinct levels. It starts at a level 1 operator, which basically acts like an autocomplete, moves up through shared control as a collaborator or consultant, steps up to a level 4 approver, and finally ends up at a level 5 observer.
At level 5, you literally just watch the logs and clutch an emergency stop button.
But counterintuitively, more autonomy is not always better. For most production business applications today, the absolute sweet spot for reliability, cost control, and accountability rests firmly at levels 2 and 3. Jumping straight to level 5, yeah, that's usually a recipe for a very, very expensive disaster.
Let's look at how this builds in a real-world scenario to make it concrete. Imagine a travel agent application. You'd let the agent autonomously explore flight APIs and check the weather at level 3, right? Because it doesn't need your permission just to safely look at data. But the very second it's time to actually pull out the credit card and buy the ticket, you've explicitly forced the workflow down to level 2 to get human approval. It's the perfect balance of automation and safety. Finally, Section 5, Avoiding Common Production Pitfalls.
Armed with all this structural knowledge, let's close out our explainer with a quick survival guide to the engineering traps that constantly derail these projects. First, vague tools. Like we said, if your tool just says gets data instead of detailing the exact schema, your agent will absolutely misuse it. Second, having no evaluation framework. If you just casually tweak a prompt without running regression tests, you're going to silently break your existing use cases. And third, missing observability. If you aren't tracking every single intermediate call, you are debugging completely blind. It becomes pure guesswork.
And despite those massive risks of silent breakages we just looked at, the industry is severely lagging here. A shockingly low percentage of teams actually take the time to build the automated frameworks required to succeed. Only 52% run offline evaluations, and an incredibly low 37% do online production evaluation. Look, if you want your agent to actually survive in the wild, you absolutely have to build evaluation and observability from day one. It cannot be an afterthought.
So before you go and write a single line of code today, I want to leave you with the most provocative engineering question of all. Do you genuinely need an agent's iterative reasoning for your use case? Or would a much simpler, deterministic pipeline work just fine? Remember, every single autonomous step compounds your error rate. Build an agent because the problem absolutely demands that flexibility, not just because it's the hot new trend. Think on that as you plan your next build.